Hi guys, let's now work on the third part of our series on information extraction, specifically knowledge graphs. So let's find that slide and get started. Perfect. So last video we ended on talking about how one can extract features and specific relationship labels using Snorkel, and then potentially pull that as a way to build training data. What we'll do now is pull all of the things from this lecture together and how to make a knowledge graph. Okay. So knowledge graphs are sets of structured pieces of information with their relationships, and they're built sometimes into a network of information between a knowledge base and the knowledge graph. Okay. And picture didn't show up at first, but here it is. So a graph might show you that Berlin is a city, which is the capital of Germany, which has the Brandenburg Gate, right? Versus France, which has the Eiffel Tower. So not only do we have the relational information, capital of, landmark of, we also have the connection between these items. Okay. And so a knowledge graph actually represents a large semantic network, and it doesn't have to be a network of places and entities. It could be a network of words, which is the sort of research that I do. But generally for information extraction, it's going to be some sort of interesting information that you've extracted from your text. Okay. And so for a long time, this was called semantic web, okay, which was a set of knowledge that could be identified on the web. And specifically, these were things that had like persons, places, events that were built into nodes. Nodes are the circles on these network graphs. And the edges, the connection between nodes, was how they were related to each other. Okay. And these two things are based on what's called an ontology. And this is a more general description of how to make network models. Okay. So in semantics, straight semantics, what words mean, this might represent having specific words that are connected to their features. So birds have wings. The have is the has a part of the ontology, and they're connected to each other through that edge. In a knowledge graph, that might be like what we saw in the last slide, is the capital of. Okay? And so this ontology specifically that a lot of folks use for knowledge graphs is called a resource description framework, or the RDF. And it's a large schema for describing things and their relationships. If you want to talk about word semantics, another version of this is WordNet that's very popular used in text analysis. And the statements are things like a subject, a predicate, and an object, right? Berlin, capital of Germany. Okay. And this is a triplet of resources that are built into this framework that you can extract and then graph. Okay. And so how do we create one of these graphs? Like, how do we get from data to the graph? Unfortunately, it's quite a process. So we will do all of the tasks that we've talked about in this section so far. We'll do named entity recognition, co-reference resolution. In the picture here, it says conference resolution, but I think they mean co-reference resolution, entity linking, relationship extraction, and then graph the picture. Okay, we'll also make co-occurrence graphs because those are really fruitful for understanding the relationships between items if you don't have a specific relation extraction capability. So let's look at some example data. And we're going to use the Reuters data set from NLTK and look at financial business data specifically, where we're going to track mergers and acquisitions. Okay? And so we might look for in the data, company 1 acquires company 2, company 1 merged with company 2, etc. Okay. And so that is ripe for a rule-based extraction, because if there's a specific language setup or structure with certain semantic key terms, rule-based extraction is going to be easier because you just write some regular expressions to extract that. Now I say that, you just write some regular expressions, right? We've talked about how regular expressions are quite difficult. And what you're going to see here is a lot of code to extract that kind of information from text. But that is actually more efficient than training a machine learning model. And you may not have the training data to start anyway. So knowledge graphs are often fairly exploratory, and we may start by using some of these rule-based extraction techniques and then move into machine learning once we have a large data set. Okay. So we're going to use the Reuters data set, like I said, and look specifically at their financial news section. Okay. Now, let us see what we're working with here. So we're going to import NLTK. And if you haven't downloaded this data set, you should. I haven't commented it out, but just as a reminder that if you don't have the data, this won't work. We're going to import that data set. We're also going to import pandas and re, because this does involve regular expressions. We're going to create a pandas data frame of the file IDs, and we're specifically looking for the file IDs that deal with acquisitions. So this is basically using a subset feature to only grab that type of data, because the Reuters data is a very large news data set, and it may have other stuff. So we're specifically only going to grab acquisitions. And that is based on the way this data set's set up. Okay. And then we're also going to load the raw text. So what this does is it finds all of the ones that have acquisitions in the file ID and then throws them into a data frame so that we have our raw text stored in pandas. Now, in this section, we're splitting them up, right? And creating a data set that has the ID, the title of the, or this is just raw right now. So we have the ID or the row number, and then the raw text. Okay. So all this code is very specific to this particular data set. You might have a data set that you just load. Okay. So one issue is that we always have to clean the data. Okay, even pretty data has to be imported or restructured or done with somehow, because it impacts the results that we might get. So normally for information extraction, we want sentence level structure. So like normal-ish sentences. Okay, what I mean by that is not just a lot of short phrases, but sentence structure. So in this example, we're going to clean out the HTML. We're going to remove the stock information that's specific to this data set, replace the abbreviations that we know exist in this data set, and drop the headlines. Fortunately, the headlines are in caps, so it does make it easier to find them. Okay. And so we're splitting up the data, and so that now that we have the original raw text, and then a column for headlines, and a column for the text without the headline in caps. Then we have a very similar function to one that we used in the first lecture, where we were cleaning up the text. And by first lecture, I mean the processing text lecture. Okay, so we're going to replace all of the HTML brackets, their codes, with the actual bracket part. Now, unescape, which is a function in one of our HTML packages, sometimes works. We had some issues with it in one of our classes, but that would also work. We're going to sub out quotation marks, right? We're going to drop stock symbols, drop stock symbols in a slightly different way. We're going to remove specific combinations of abbreviations. So $DLR, we're going to fill out to say dollar completely, MLN for million, okay, PCT. So we're also going to normalize all of the shorthand abbreviations, okay, into capitals. So Co, Corp, Inc., PLC, LTD. Notice how these are very specific to the question at hand. Okay. Take out quotation marks, deal with white spaces, fix acquisitions being misspelled in the data set. Okay. Fix this typo in the data set. So obviously at some point, someone's looked at this data and figured out that there are only a couple of spelling errors to fix. And fix all of those. The cool thing is you can use this function, not just apply, but this function called progress map. So it'll give you a little progress bar as it goes. Okay, this works the same as apply. So now our text column is the raw text cleaned up. Now, what we want to do is find the things that only have uppercase letters. So this is still a problem specific to this data. What we're looking for, so look here, right? The raw text that is only upper, okay, and print out the headline and the raw text. And so this basically says, okay, find everything that is upper and print it out so I can just look at it to make sure that I'm not losing anything I'm interested in. And so what happens is sometimes the headline is the only thing in the text. So we have the headline and then the headline again. There's no actual text behind it because it's an old data set. And so we're going to drop everything that is upper by using this not function. So only hang on to the data that's not in uppercase, okay, in the raw text column. Now, we want to process this with spacy's named entity recognition, but what we're going to do is build a pipeline through spacy that'll actually do all of the steps together. And so what we are taking is we're leveraging a system that already has a lot of this information in it and adding to it. And so I took a screenshot of this from the book, but it has a lot of the types of named entities that you might find in spacy. So person, NORP, which is a funny one for political, religious groups, facilities, organizations is mostly what we're interested in. GPE for geopolitical entity. That's things like countries and cities versus locations like Mount Everest, right? Products, events, so hurricanes, sports events, work of art, law, and language. So we're going to use these to extract the pieces that we're interested in first. So import spacy, import displacy. We're going to talk about how to make some visualizations here. Load the small language model. And at the moment, we're just going to tell it to print the pipeline that is already embedded into spacy. Okay, we haven't done anything to this. This is the pipeline that spacy has naturally. Okay, so toke to vec is a token to vectors information. It's kind of like word to vec, not completely. We won't use that one. So taggers, we got to know the parts of speech, right? Parsers, this is the structure of the sentence. Attribute rulers, right? Limitizers and NER. So we're going to start there and add new pipelines to spacy. So entity ruler, which is a different form of attribute ruler, allows you to add entities to the NER pipeline. Okay. It works a bit like regex, but it's a little bit better than just straight regular expressions because it's part of spacy's neural net pipeline. Okay, so it can learn as well. And so we're going to add an example of government departments because we're interested in sort of the mergers and acquisitions, which is controlled by the SEC. Okay. And so from spacy pipeline, we're going to import entity ruler, okay, which is a pipeline that we can add to our model. And we're going to look for justice and transportation. We're going to add some more in a little bit, but let's start here. So the Department of Justice, right, might handle some of these mergers and acquisitions once they get themselves in trouble. Okay. I'm not sure why the book has the example for Department of Transportation, but we're going to add that one in. Okay. And so the hardest part about this is setting it up properly. Okay. It is a dictionary, so it's a list, overall a list, with a dictionary of dictionaries. Okay, so let's look at this first one here, because what we're adding is 3 entities to look for. So the entity label will be GOV to fit, to add a label to their system for gov. We could do GPE or we could do, I don't know, it's not a business. So gov makes some sense. So you could pick one of theirs already or add a new one. And so the pattern that we'll look for is text US. And the OP here indicates that it's optional. Okay. And so we'll look for US, and that might be optional, followed by Department of, followed by one of these, justice or transportation. Okay. And the entity type is an org. Okay. So this basically says, find anything that says U.S. Department of Justice, U.S. Department of Transportation, or Department of Justice, or Department of Transportation. The U.S. part's optional. Okay, so we're filling in because people tend to write it with this structure. We could just have the department name first. So U.S. optional, Justice Department, which would be a little weird, Transportation Department. Okay. So the words are being filled in here, and then this one. Okay. The in part makes it clear that there's more than one. Or a completely separate one, Securities and Exchange Commission. So notice that it's broken apart here by brain fart, by word, okay? Because that's how spacy processes things. Each of these will get labeled as gov. The specific one does have an int type associated with it. So that means that normally this entity, justice and transportation, will be classified as org, but in this case, we're going to label it as gov. Okay. The easiest thing to do wrong here is to miss a closing curly bracket because it's a dictionary of dictionaries, or it's kind of a list of dictionaries. It's a list of dictionaries that have lists. Key pattern lists. And also to get the regular expression wrong. But since it isn't actually using regular expressions, it's using more straight, this sort of fancy JSON format, it's a little bit easier. So you got to think about all the ways that this might appear in the text, okay, to write this well. And so we've got U.S. Department of blank, or Department of blank, U.S. blank department, or department, like department, so to speak, like fill in the blank departments, or Securities and Exchange Commission. Now, what about those abbreviations? Because a lot of people write DOJ as DOJ and the Department of Transportation as DOT. So we will expand those in a different component. But here we're adding the expanded version as an entity, so it will get captured. Okay. Now, how we add the entities to the pipeline. Okay. And actually, the book, it suggests removing the pipeline and then removing the pipeline and then adding it back. I don't know if that's necessary, but I will say, here's what the book tells you to do. Okay. But either way, you build an entity ruler. So we put entity ruler, NLP. What's NLP again? That's our spacy model that we're adding to. Patterns equals patterns. Patterns was this page. Okay. Overwrite entities true. So if they already had a name in there, we're going to overwrite it with our new name. So it comes up as GOV. Okay. Ruler, add NLP.add pipe entity ruler. So we're adding that in. Now, this is a little unusual because the book has this wrong. Normally, you just do NLP.add pipe. You'll see that in a minute. But this one specifically requires that you do two steps. It requires that you do add pipe and then add patterns. Otherwise, you'll get an error that there are no patterns to be found. Okay. So ruler.add pipe, ruler.add patterns, and add the patterns to it. Even though patterns is here, that was the only thing I could get to do to where it actually worked properly. Okay, so let's test this with some text. And we can use displacy to show off the entities found in the text, which is a really pretty view of small amounts of text, right? So Justice Department, the U.S. Department of Justice, DOT, Securities and Exchange, but the Sales Department is not. Okay. Now notice that it still found Sales Department, and it labeled all of these as org, so it's not totally perfect. Okay. Now, how could we normalize them? Okay. So we want to, like we've already done the text normalization, but this is normalizing the entity names. So we want to standardize the names to help with the linking between them. And what happens sometimes is, you'll notice here, the Securities and Exchange Commission. So in some cases, it will pull in either a possessive, the apostrophe S, or contraction, and the word the. Okay. And so I'm sorry to Ohio State University, but the word the is not necessary. So we'll remove that from the text so that we can get all of the mentions together. Okay. And so here's an example. Baker's International shares, Klein's New York Stock Exchange. If we process that with our spacy pipeline before we fixed it, print out the entities, you'll see that the apostrophe S and the get stuck in there. And that would limit us from combining them to the same object later. So we can add what's called language components to spacy 3. So the book has both versions. It has spacy 2 and spacy 3, but they're really going to move to spacy 4 soon. So we're going to do spacy 3. Okay. And so we're going to leverage their part of speech tagging to remove those patterns. Okay. So to do that, it's a little different. You do @language component. So this is where you're making your own pipeline. So we can add pipelines that are already available in spacy, like entity ruler, or we can make our own new pipelines. Okay. And they're basically like little functions that you run on the data. So it's kind of like an apply function. And we're going to call this one norm entities. Okay, you've got to have this first line or it will not work. Then you just define it as a function. So for each document, hold on to the entities. Okay, we've got an empty place to save them. And then for each entity in doc.ents, because it's run through all the other spacy pipelines first, so you do have to put them in order here. The pipelines need to be added, otherwise this entity thing won't be there. If the first entity is equal to a determinant. Okay, so if entity 0, that's the first entity in the first entity listed. Okay, so the first word in the entity is a determinant and the A, then delete that bad boy. Okay, so span says take the entity from our document, one word in to the end. If the length of the entity is greater than 0, okay, so this will capture empty entities, which does happen. If the last entity is part, okay, so -1 means last. If the last entity is a participle, okay, or a particle, then do everything up to but the last one. Okay, and this one handles apostrophe S's. And then return the document entities as a tuple. Okay. So what we're going to do is apply that to our pipeline. So we've removed the first one and the last one. So we just do nlp.addPipe norm entities. It will tell you, hey, you did this. Okay, because we didn't save it as anything. Now let's print out the NLP on our previous text, and you'll notice that we've gotten rid of the apostrophe S and the at the beginning. So now we've eliminated those from our examples. And so the displacy just allows me to show this to you a bit more visually, where the apostrophe S and the are now pulled out of the entity recognition. Cool. So we've added new entities and cleaned up them so they match. Now let's merge the ones that are all the same. Okay. And so instead of having a bunch of tokens, we want a phrase. We want the entity to be one token instead of multiple parts of speech tokens. We just want the entity to be Baker International or New York Stock Exchange. And so we can do this based on spacy's merge entities pipeline. So notice there's no language component here because this is one they've already built. So import merge entities, remove it if you want, I guess, and then add it. I think the removal is so that you get it in the right order. I think that's why they have you remove it first, but I'm not 100% because it just says this makes it easier in their notes, but that would be my guess. And we're doing these in a very specific order on purpose. Okay. And I think once you made a picture, you would see the ones that weren't good, the output wasn't good, and you could go back and reprocess. Okay, so we're adding merge entities, and we're printing them out one more time right? Baker International, New York Stock Exchange. So now is one entity as opposed to a list of words that belong to one entity. And so honestly, this is like the paste function. It adds them all together and makes it in one object. Now, coreference resolution. Okay. And so this happens when you are trying to make all of the same objects be the same. So now that we have them as one word, how do we make sure that all the different Justice Department options are listed together? So if we look at this sentence here that they're using as an example in the book, and then make a graph, a knowledge graph of the options, or this is more of a co-occurrence graph. How do we go from the one on the left to the one on the right? Okay. And here, the wider the band, the more they occur together. Okay. And I will 100% tell you that I think we're going to do this with Python's NetworkX, but ggplot is so much better, and gggraph is even better than that for these kinds of ones. So while this is a Python focused class, if you can take the referencing information and export it into R, you would have some really great options for making really pretty graphs. This might also be my R bias talking, but I will tell you that I've been very frustrated with NetworkX, and that might be my inexperience. Okay. So how do we make those come together? Okay, and that task is called coreference resolution. And so here is an entire set of things that have to occur for that to happen. Okay, so we've got our entity ruler, our norming of entity, and our merging, and then this whole thing is the coreference part. Okay. Entity linking we talked about before. This is where you would link an object to some known knowledge database. It's maybe not necessary for a knowledge graph, and the only real free option is DBpedia Spotlight. And you can add that pipeline, but I will warn you, their API has a certain limit to what you can do. Okay, because I hit it trying to make these notes. So we'll create an initial sort of mention cluster. So initial coreferencing. We'll resolve aliases like SEC becomes Securities and Exchange Commission. We'll name resolve, so we'll link together all of them that are the same. And we'll do anaphora referencing. Okay. Now, in this case, that is actually done with neural coref, which is a really great package that doesn't seem to work with spacy 3. So there are different ways that you could do this, but I would say if you can do anaphoric resolution, it would be cool. This is things like pronouns. It's, their, your, ours are used to refer to it. Okay. So that I can think of some ways that you can write this, but it won't necessarily negatively impact your graph too much, because it just will drop the number of co-occurrences because those words will get ignored. And then we can normalize the names. So let's start with linking names together. Okay. And what this does, this is a specific way to do this in spacy called initial coreferencing, pulling everything together. And so we're going to import token, which is one of their functions. And we're going to remove ref_n and ref_t from their function names first. We're going to make two extensions. So I've already imported it once. I've just got it on here twice. We're going to set ref_n and ref_t and define this function. So for each entity in our document of entities, if the entity label is organization, government, or person. Okay, we're looking very specifically for these three entity labels. Then set ref_n as text and ref_t as label. Okay, so we're going to say if it's one of these three labels, grab reference in the name and the reference text, the label. Okay, so all this is doing is just grabbing them. It's like, here's everything that's an org, a government, or a person with the text and the labels. Okay. Now, this part's a little gross. It's kind of a lot of gross, actually. But how do I combine them all? Well, you look at them and you manually combine them. And there's nothing fancy here. It's just a lot of code. Okay. So we're going to display NER. The display NER is actually a function that they've added on from the book to display named entity recognition for our custom system. Okay. So essentially, they've basically added the fact that we've got these new pipelines in here, and it should display based on the new pipelines and not just the old NER pipeline. So that's what this one does. Okay. This one makes a pretty dependency tree, right? Neither of those are necessary. They're just useful functions. So let's look at what actually is doing the work here. How do I make sure that everything comes out and looks the same? And that is just to find and replace. So here are all of the acronyms that were in those entity lists. So effectively, we found the ones that were the organizations and the governments, and we printed them all out. Basically, you could make a counter, a table of them, especially now that our class has figured out how to do this. So we take all these entities, we print out a frequency table of them, sorted by name. And then you come up with this list. Oh, okay, AMC is American Motors Corp. And so you just essentially are fixing all the typos. It's another great place to fix typos. You're correcting all of the shorthand abbreviations to the long versions. And this would require you understand what the data is, obviously. Okay. So you make this acronyms list. Okay. And we say alias lookup. So I don't know why SEC is not just at the top here. I think it probably just got added later. Like, I think these were from a previous chapter's example. And so we're adding our new acronyms. So we're creating the acronym list here. So this is a dictionary of key value pairs. Then within that, every one of these is an organization. Okay, so we're adding a entity text to it. Okay. So basically saying like all of these entities should be labeled as orgs. Okay. For SEC, we're adding it in as a tuple, okay, of the expanded definition for SEC, so Securities and Exchange Commission, and it's a government entity. Okay. So essentially this becomes AMC is American Motors Corp and org, AMI American Medical International Inc. and org. Okay. So this is just a shorthand way to add the same label to all of them. Then we're adding a couple more here. So the U.S. Department of Justice is a government, and it can be listed as any particular one of these three: U.S. Department of Justice, U.S. Justice Department, and Justice Department. Okay. So this is a shorthand way to add a large set of key value pairs. Okay. So it has one key, or it has the key pairs, and then all of the ways that it could be listed. Okay. You could also do this one at a time up here. Okay. So we're adding Department of Justice, Department of Transportation, this organization, USA Air Group, and Trans World Airlines. And so this is sort of three different ways to handle the same problem. The problem is we need a key to a value and an entity. Well, these are the only real issues with them. So expand these acronyms out. Then also add SEC. But last, so to speak, we have some that have multiple potential listings. So this is the final key value pair that I want. I'm sorry, not key value pair. This is the final tuple. I want all of them to say U.S. Department of Justice, gov. And these are all the potential keys that go with it. So if you see in the document, the key is what might be in the document, make it this value. If you see DOT, make it this value. Okay. So there's no particular reason to have like three different ones, except they're showing you different ways here to handle a bunch of acronyms versus a bunch of keys to one value. Okay. So then we update our lookup table. And so the lookup table is simply finding that piece in the text and converting it. And so this is an example of what it will do once you use the lookup table. Okay, so for Transportation Department, it converts that into U.S. Department of Transportation, which is government. For SEC, it converts that to here, Securities and Exchange, and that's government. So this is what it's going to do. Now, how do I actually apply that in our pipeline? Okay. So we'll write a little function called Alias Resolver. Okay. And it says, okay, for all the entities, what is the first entity's token name? Okay. And so if the entity token name is DOJ, if that token is in the alias lookup, well, DOJ is in the lookup, then grab the name and the type and add it to our new name type placeholder. Okay. And propagate entity type just puts it back into the pipeline. Okay. And so basically, propagate entity type is actually defined here, sorry, but what it's doing is putting it back in the pipeline. So for all of the entities in the document entities, basically for the entity we're currently working on, figure out where it starts and ends and add it back into that tuple pipeline. So let's look here. The deal of Trans World Airlines, which is one we're going to convert, is under investigation by the U.S. Department of Transportation. The Transportation Department will block the deal of TWA. And what that's going to do is display. So we're using our display function. At the moment, it's not fixing them, but it does print out that they are both government agencies, right, and orgs. And what this will do once we apply this pipeline is it will transform them into all the same word. Okay. All right. Now, name variations sometimes are when things happen. The first time it's listed as their whole name, and then maybe the next time it's listed as part of their name. And this is most commonly done with human names, right? So if I said Dr. Buchanan, blah, 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 then later it's just Buchanan, blah, blah, blah. I found this very awkward when people write this way because I still have a first name, right? But this is the way that a lot of articles are written, right? And so what this does is it will look up and convert them all to the same thing. Okay. Now, one problem that we're having here in our output is that we're not seeing the whole table. So it doesn't look like it's changing. I said a minute ago, it didn't change it, but what we're actually seeing is that we're printing the original text, the entity type, and then the new reference and reference to the new stuff. And those are actually corrected. You just can't see it all in the not awesome printout format. Okay. So when you're looking at this, running this one line at a time in Markdown, for example, which is how I did this, you'll see that it actually does convert them properly. Okay. All right. And we'll see that in our final picture as well. All right. So find, okay. So sorry, first resub, ignore parentheses and dots because abbreviations. Find the word boundaries. Okay. So remember that /B here means word boundaries. So don't pull an abbreviation from the middle of the word because SEC is the first part of secretary. So don't screw that up. Okay. Clear out all the spaces, right? So no extra spaces, squeeze them together. Okay. And return the object as long as it's not none. Okay. So once I clear out the spaces and mark the word boundaries, if it's essentially no word there, just move on. Okay. And so our name resolver okay, says, okay, find all the entities that are listed as org and person. Okay. If the first, if the name for the first reference to the entity matches the second text, then rewrite them. Okay. And so here, Trans World Airlines and TWA are both converted into Trans World Airlines, partially because we already did that with the previous acronym resolver. But here, this would resolve first and last names. Okay. And so essentially, we're trying to see if the last name of the first one matches the last name of the second one. Okay. And it does work if we saw all 4 columns. Now strip all the legal suffixes. This could be Mr., Dr., Esquire, Junior, if you're doing people's names. But in this case, we're doing business names. So we're just going to take all of those off. Okay. This is a simple regular expression where it just says, if you see any of this stuff, delete it. Okay. So if we do strip legal suffix, it comes out without the co. Now we're going to call that norming names. So if the reference name isn't blank and it's an organization, then strip the legal suffix and return it. Okay. And we've added that pipeline in. Okay, so we've gotten through all these different pipes. How would we figure out how to do these? You would make this graph, it would be hideous. And then you would go through and find ways to prune. You'd say, oh, I need to take all of these acronyms out of here and convert them all to the same. Oh, sometimes people just say huges, and I need to make sure that that's resolved where it's the same name. And so my recommendation actually is to get through most of the initial coreference resolution and then just print out a table of them. Hopefully there's not millions. And especially, you don't want to make these graphs with thousands of points anyway. You won't be able to read it, and just go through them and say, okay, this one and that one are the same thing. And so we need to fix that. How do we fix it? Well, I could use a regular expression, or I could say expand this acronym. Okay. So once we finally have all of the data together, let's start with making a co-occurrence graph. I personally think co-occurrence graphs are like the coolest thing since sliced bread, but that's because this is what my research I use to visualize stuff. But essentially what a co-occurrence graph is exactly how it sounds. It displays entities, in this case, that co-occur together in the same document. And one of the most famous phrases in word nerd land is if words that are related are in the same documents. Okay, so if they hang out together, they're probably friends. And so they're related in some fashion. We could say that they're semantically related, meaning they have similar meanings, or in this case, they're related to something thematic. So they're all businesses because they're in a document about businesses. Okay. And so we can start to map relationships because they just happen to occur together in the same document. Now, document we can define as the entire paragraph. We could define document as one sentence. We could define document as like a whole news article. So that level is dependent on your own interest. A lot of people use sentence level documentation, but for some of these more complex, if we're using entities, we might consider like paragraph or whole document level co-occurrence. And so we may not know the exact relationship from these things, but having them linked together and having a picture of it gives us a big clue. And this is a pretty graph version that they made with Gelfius, and I think how you say it, but I can't get their output from NetworkX to work with it currently. And if I look on their GitHub page, it's a currently like to-do list item. So we'll look at the graph from NetworkX, and then I will tell you that if you go look at Tidy Text Mining, the book, there's a really great example of making a network plot with gggraph, and it's really pretty. So this is what one might look like, okay? Where each dot is a node with a name, okay? And the strength of the connections is wider for more connections. And this gives you an idea of the communities in the text. So everything here is tied to the SEC. But we have like oil and petroleum. We have TV, music, communications, aviation, Citicorp, audio, video. Okay. So it's kind of interesting that they aren't paired with TV down here. Reuters. Right. We've got cars, and this must be financial stuff. Okay. And so this is a really great exploratory analysis for understanding the underlying kind of connections in the text. So let's look at how to make that. Okay, so how do we do this? Well, we're going to use our new fancy NLP pipe to run this, and I will tell you this is very slow because not only are we piping everything, we're also grabbing those co-occurrences out of the text. So pull up your sleeves and prepare to wait, because the more text that you have, the longer this takes. So we'll say this document, because there's 2 of these in there, it takes like somewhere like about 8 minutes to knit the slides, and it's all because of these 2 slides. That's not terrible for 2,000 documents. That's going to be better on better computers. But if you have millions of documents, you might rethink some of this. Okay. All right. So we're going to import math to get the ceiling and TQDM. Now, don't do the stupid that I did that took me some Stack Overflowing to figure out. But TQDM is a function in TQDM, the package, because that's not confusing at all. So be sure you say from TQDM, import TQDM, or you're going to get a weird error message that thankfully someone has answered on Stack Overflow. Okay. So let's make ourselves a function. Extract co-occurrences from the document and include the type of thing it is. Okay. So our entities, our list of entities, okay, is the name reference and the label. Remember, that's the entity. So name reference and label is the original name and the entity type for every entity in that process document. Okay. And include types. So include types here is where you can set what kind of entities you want to pull out. Okay. Now the set function here means don't repeat them. Okay. So this is the list of all of the entities and their combinations. So if U.S. Department of Justice is listed as gov once and org a different time, it will actually come up as 2 different ones, but we've handled that previously. Okay. So create a unique set of entities and their names, okay, which is why you gotta normalize them first. And the yield from, make the combination, so count, basically. Now the batch size here, you can set it to whatever you like. I did it as 100, so it'll do 100 documents at once. And the number of batches is based on the length of my data frame. Okay. And for I in TQDM, range 0 to length, right? Based on batch size, and run a total number of batches. So this allows us to like process this in chunks so it runs faster. Okay. Run the pipeline. Okay, on our text column is our cleaned up one that we did the basic level cleaning, and our pipeline is like everything that we've told it to do on I to batch size. Okay. And I here is going to increase based on batch size. So basically this says run from 0 to 2,900, I think, rows based on batch size. So 0, 100, 200, 300, 400. Okay, so I is increasing in units of 100 because that's what we did, up to the total number of batches. Grab those first 100 documents, okay, and try to count the entities that are either organizations or governments. So this line here adds the co-occurrence output to a data frame. Okay, well, it's a list actually. Okay. If it doesn't work, print the index and print that part of the data frame and blow up an error. Okay. So try to run it, and if it don't run, here's an error message so that you can figure out why it's not running. Okay. Now the cool thing about this package is it's going to write me out some output here. So this tells me, you know, how long it took, how long it ran. So this is how long each batch took. So that's why it takes about 8 minutes, because you'll notice here that some of these batches took almost a whole minute all by themselves. And now just to print some of our co-occurrences. Okay, so the first one is here. There are 545 co-occurrences of American International, which is an org, and the Security and Exchange Commissions, which is a gov. There's 1,735 Trans World Airlines and DOT, and US Air Group. And so now we've got a tuple that has the number of co-occurrences, the first occurrence type, which is the name and the little entity, the second occurrence type, name and entity. And if I convert that into R, I could treat this as a data frame and use the gggraph option to calculate based on frequency, and I could color them, for example, by the type of entity. I just really like gggraph, but let's see how we do that in Python. And so we're converting this into a pandas data frame, right? So we've got their ID, entity 1, entity 2 for each of these. Okay, so the ID is the number of times something occurred. Entity 1 is a tuple, entity 2 is a tuple. And make some columns. We've got the article ID, the entity type, int1, type 1, int2, type 2. So this converts it nice into a pretty format instead of the structured list of tuples. Now, this functionality I think is really fun, mostly because I have been playing with SparkX, Apache Spark, PySpark. Meh. And so this kind of actually pulls in and runs this a little bit. To me, it looks like PySpark. And I didn't realize that I could do this with pandas in regular Python. So that's kind of fun. But I do wish they hadn't completely switched types here. But group by, okay, group by groups it by the the pairs of entities. So group by essentially, just like dplyr, groups them together, where what we see is that like this set do something on this set. And if the other set is slightly different, do it on that set. So it kind of keeps together the pairs and their types. So it'll calculate this once for all pairs and types. Okay. Ag. Okay, ag here means to count. We're creating a count and a sum. Okay. And so what you see is you end up with the frequency column of the number of types. I lied to you. This is the article number. I lied. I forgot this. This is in this first article number 545, we have these two listed together. In article 1735, we have these two listed together. That's my fault. Sorry. So now we have a data frame of the article numbers, and we want to sum them up. That's my bad. So ag here means count. Okay, count how many times this combination occurred. Now sum here is a little weird because what it actually does is, since these are text components, it just like creates a list of all the articles in which they're paired together. We're going to rename the count column into frequency and the sum column into articles, so it's more readable. And reset index on pandas here, we'll just make it a list of like the row names will be 1, 2, 3, 4, 5. Okay. And let's see, articles. Oh, okay. This joins them together with a comma. So this is what output we end up with. Okay. And these are the articles we could go pull to look at how they occurred together if we're interested with. And so let's see what that looks like now that we have it in the right format to make a graph. Now I will tell you, I'm not that great at NetworkX at all. But here's how you do this in Python. Okay. So we import NetworkX, and you must remember to import matplotlib because it uses matplotlib in the background. If you don't, none of the code at the bottom will work and you'll be sad. Okay. So inx.fromPandas, cool. We tell it what columns we want, entity 1, entity 2, the article numbers, which I don't know where these get incorporated, and the frequency. Okay. We're renaming frequency to weight because it likes to have the column name for the strength of the pathways to be weight. Okay. Source entity, target entity 2. Okay, so how are we connecting them? We're connecting 1 to 2, okay, based on this weight. Edge attributes true. Now I turned this part off because it made me a little triangle, but if your document is too busy, there's too many things on it, you can tell it to graph only specific components. Okay. I turned that off. So this is just one of the mini layouts that's available in NetworkX. This is how big to make the picture. Now draw me the picture. So we're going to draw the graph and the position. Okay, POS here stands for position. Node size 1000, node color sky blue, alpha 0.08. Alpha is like how transparent it is. With labels equals true, so it puts the words on there. There are so many things you could do to make this prettier. Okay, as long as you can get it into a graph, you can use it visually. But if you're wanting to put this on like your website, definitely spend some time looking at NetworkX's documentation to make it better looking. Now, we've drawn all the dots. Now we have to connect the dots. So for each node 1, node 2, and their data, graph the edges. Okay, the width is based on the weight from above. Okay. Draw network edges, graph part of speech, edge list. Node 1, node 2. Node 1 and node 2 are entity 1, entity 2. Width equals the width. My edge color here is black, well, light gray. And alpha is 0.05, 0.5. Okay. plt.show, so show the picture. And this is what we end up with. Now, what could we do to make this better? One, we can make the font size larger. Okay. And I tried to close the graph, so it would stop giving me this cute little thing. But this is a problem with Corto documents, I think. So just kind of ignore the white boxes. That won't go away after this one. But what we see here is where's DOT, Department of Transportation, is only one word. Department of Justice, only one word. So proof that all those documents later, it's only one node instead of multiples. Okay. And what do we get? Well, we get a little group of folks up here. Okay. In the Securities and Exchange Commission. So we've got this bank, the Presidential Commission on Good Government, San Miguel, which I don't totally get. That might be a label that's just not correct because it doesn't appear to be an org or business, but I could be wrong. That's a place, I thought. And then what we see is this like 3-part system of Trans World Airlines, U.S. Air Group, and the DOT. So I'm sorry, yeah, DOT. So there's a lot of action going on here in those articles. So that might be the time period of something going on, which is kind of connected to another airline, American Motors, right? The Interstate Commerce Commission, which isn't too surprising. It's not too far away from Motors. Okay. I do think it's interesting that those go through Department of Justice and not Department of Transportation, but okay. The FTC, right? And so we can kind of start to see some little families occurring here, but the biggest 3 connections are definitely these. And that's what this graph giant component will do. It will pull out and only graph just this one. Don't do that. You'll lose some information. Do it later after you've looked at the main picture. The other thing you can do is in your pandas data frame, exclude a lot of the low-level frequencies. So if you had a ton of data, you could say, okay, only give it to me when there are co-occurrence frequencies over 10, for example. Now, the last component here is for the actual knowledge graph. And I would say this doesn't work very well in this data set, but I was kind of like 87 slides in, so too late. But what we could do is pattern-based relation extraction, okay, based on the sentence structure. This would be arguably it's not easy because you've got to figure out what the pattern should be, but it does require sort of less data to get started. And you'd modify that information based on the topic at hand. So if you're talking about spouses, remember with Snorkel, we did like married, wife, husband, right? If we're talking about mergers and acquisitions, we're going to use merge, acquire, that kind of stuff. And so we're going to use acquires, sales, subsidiary of, or chairperson of. Okay. And one of the issue with this analysis is the ambiguity in which we write things. So, we don't always write using the word acquires or merges. And so the sentence level structure may be different across these different examples. So we kind of have to figure out how to deal with the fact that things are written in different ways but mean the same thing. Okay. And so we'll build this giant pattern matcher. Okay. Whew. So buckle up, right? So we've got spacy.matcher, we're importing matcher. Okay. And we're going to grab all of the vocabulary that happened in our NLP when we ran NLP. So here's the vocabulary list of things that are available. Okay. What that does is it gives us all the different options. So I think this would handle acquire. It handles acquires. We could do buy, bought, purchase, purchased. So we could capture all of the different potential combinations, and we could really focus on the lemmas here. So we'll talk about that in a second, but we're going to do the 3 root lemmas: acquire, buy, and purchase. So bought being the past tense. Okay. Whoever the subject is. Okay, so this is empty, meaning whatever's listed there as with this subject, who is an organization, followed by a reference not in the organization, but that's optional, followed by our verb, where the lemma is in these 3. Okay. So that controls the past tense of purchasing, purchased, purchases. Okay. Acquires is apparently a weird one because acquires doesn't seem to map back onto acquire singular. So Spacey's lemma detection is not perfect. Okay. So this just gets both of them. But by using the word lemma here, what we're saying is, like, as long as it's the original word is by, that's fine. Okay. So any particular subject name that's an organization, potentially followed by something that's not an organization, but it's optional. Since remember OP here for optional. Followed by one of our words. So we could say General Motors acquires something, right? Followed by something not in an organization. Again, optional, followed by org. Okay. So effectively, we need to say something like General Motors acquires Apple. I don't know, that wouldn't work, but that order. And it will also pull and allow things to be in between. Okay, so like the chairperson's name or something else. Okay. And this was determined by looking at those patterns. Now here's where we can get subsidy of or unit of, right? So subject's name, not something followed by not an organization, where the part of speech is not in the verb, but it's in the synonyms of the verb. So this handles subsidy of, unit of. Okay. Something not in the organization, part of speech, not in our verbs, and it's optional. So this one will handle General Motors, a subsidy of Chrysler. Let's see the other way around, right? Or whatever it is. Okay. So these look for those particular patterns. Okay. And this function here deals with the patterns. So here are the patterns: extract, relationship, match. Now for each sentence, for each match ID, start and end in the sentence, find how long the item is, look at the rule names. The subject and the object of the sentence are the first one and the last one. Okay. And this one will handle the reverse. So if the items are reversed, still keep them connected, right? So if I say my other one the other way, Chrysler, a subsidy of General Motors, or if it's General Motors, a subsidy of Chrysler, like that would keep them counting as the same thing because they're just reversed. And yield, what it's gonna return is the reference in, reference t, the relationship between them, and then the reference in, reference t for the object. So the first object, it's prediction, so it's pattern subsidy of, acquires, okay, and then the second one, and one more pattern, reverse, the reverse subsidy of. Okay, now I don't know why it prints, but it doesn't show the it shows this big white box. This is like a weird bug going on. But essentially, Fujitsu, I can't say this word, plans to acquire 80% of Fairchild Corp. Okay, so it would grab the first word here, acquire, and Fairchild Corp, which is an industrial unit of Schlumberger. Okay, so we'll grab Fairchild Corp, unit of Schlumberger. Okay. And so it would extract those, and then here you could, if you run this code, it'll print out for you. Okay. Now acquires is a weird one. So if we look at the output, and you see the output, acquires doesn't work that great. So we added it in to our pattern match here for acquires and ran it and went, oh, if. Okay, because people use acquires in a lot of ways. So we're actually removing it. Okay, that's not necessary. You would look at the output from some of the text and go, oh, that didn't work right. Okay. So instead of using pattern matching, okay, we could instead use dependency matching. Okay. Now, dependency matching is a bit more complicated, which is why the code's longer. But what it does is it grabs the dependency parsing structure. Okay, so dependency parsing structure is where we have a verb as our main kind of root word. And from that, we get the subject of the verb and the object of the verb. And we're looking for acquires, for example, that's going to have a subject and an object. So we can pull out the sentence, find this specific verb, and grab its dependent in subject and its dependent in object. Okay? And that's what this does. So it walks through and says, if the child dependency is one of the entity types we're looking for. Now, the child dependency is if the root word is the verb, it has a child, and the child is the object or the subject. Okay. And so if the child is one of our entities, return the child, else do something else. Else, if the child dependency is a compound. Now, this is for compound phrases, like Fairchild Corp is actually two separate tokens right now, and they're listed as compound words. So it just allows you to grab both parts of the compound. Okay. Check it. And so if it's part of that, return the child. This part deals with passive voice. Okay, so finding when you say was acquired by. So this allows it to handle passive voice. Okay. Find the closest subject in the predicates of the left or the parent's left, right? So this find subject takes the passive voice option and finds the subjects based on the passive voice. And find object here finds the closest object when in the regular voice. So the object is the second word. I kicked the ball. Kick here is our word. I am the subject. The ball is the object. So that now we have the connection between the two, acquired, subject and object. If you said the ball was kicked by me, oh, so awkward. We've still got the same pattern, but now we're dealing with the passive voice where there's an auxiliary word in there, was kicked. Okay. And so that's what all this does. Okay. So let's put all that together. Okay, so this is everything. So we've got our patterns from before. Okay. And so we took out acquires because we're going to let acquires be handled by the dependency tree because we figured out that the pattern matching doesn't work very well for acquires. So find subsidiary, find unit, add all these things to it, find chairman, president, director, CEO, and executive. So we're going to pull out the people involved in these relationships too. Okay. And we're going to do extract relationships from our documents. Okay. And so we'll extract the relationship match. We'll extract the relationship dependency using acquires, and to extract the relationship dependency using cells. So the matches occur from right up here, okay, based on these words. And then we'll also use those two verbs. Okay. Now we run this code. I really don't understand this picture thing, but what it does is it prints out our pretty graph down at the bottom where it tells us how far we've gone. Okay, so we'll run 20 at a time for the full number batch size. We're going to run the same thing here, pipe it through. And here we're just going to extract the relationship. So relationships.extend is basically adding, here are all the relationships. So we're going to end up with a list of lists of the, return all the stuff from extract relationships. So we'll have item number 1, the relationship, and then item number 2. We'll put this into a data frame of article, subject, subject type, predicate, object, and object type. I'm sorry, not predicate, relationship. Okay. You can't be both the subject, you can't acquire yourself. Okay. So take that out. This is just an issue with the tokenizer. So take out things that start with own, drop the duplicates, and aggregate them together. Okay. So this code, very similar to the previous code. Now I will print out some value counts, and in just a second, I'll go back to the markdown and we'll look at some of the outputs for these. Okay. And make the graph. Now this graph is not nearly as great because it won't print the relationships between objects in the multi-die graph mode. And I'm not sure if I turn this off, it will. But the multi-die graph is supposed to allow you to export this to a separate program called Gelfi, but it's not working because the code is outdated. So I just told it to print straight from the visualization here, but now we can start to see how these are directly connected through the text as opposed to co-occurrence, right? And so we'll pull up the chart here that produces in just a second and look at what is actually in the data frame. But at the moment, because we've turned on multi-die graph, we can't get the relationship to print on there. Okay? But there was a reason why you needed it. All right. So let me wrap this up. I'm going to get my markdown started, actually, because it's quite slow. And we might have it already, although it does tend to give you, yeah, so it's already pulled up, great. It does tend to lock up sometimes because of the displacy output. And I want to show you one more thing about displacy before we go, but let's wrap up. All 3 weeks. Oh my gosh, we've done so much code. Okay. And what we'll do together in class is see if we can modify this code on new data, because that's the hard part, right? It's thinking about, okay, well, how can I apply this to a completely different field and different topics? And it requires a lot of thinking. Okay, there is a lot of digging around when you're working on extracting information because of the flexibility in language. Okay, so what we covered was key phrase extraction, which required some part of speech tagging, named entity recognition, and linking those named entities to a dictionary database. Okay, relationship extraction here at the end, and how to put all of that together into sort of a final output of a knowledge graph. Okay, so let's go back to Markdown real quick and look at some of the outputs that were sort of weirdly blocked by my nonsense. Okay, so as we're removing things and we're dropping duplicates, this is the chart that we end up with. Okay. Oh, geez. And it's still not great. I need to figure out if I can make this Jupiter. Do I have objects? Is this fake run? I think so. So I don't have it saved. but we do end up with what articles they're in and the frequency of them occurring together, right? And then we're having it print out the relationships. So let me hit this button so I can run everything. And I will warn you, it is a little slow. It also prints much better when you're working interactively. Okay. And so we'll look at some of these graphs, or not graphs, some of these outputs that we couldn't see before. And we'll turn off this silly output. So this is one of the many things that annoys me about Markdown sometimes, is this output. But what is that crazy output? Well, the problem there is spacy. So all this is fine, yada, yada, yada. Still running, as you can see at the bottom. It's still thinking. So this output's fine. Where's that displacy? Let's find it. Okay. So displacy is really cool. But no matter what you do that I've seen so far, if you're using Jupyter, it shows up fine. If you're using R Markdown here or Quarto, like I'm using, it shows up like this. Okay. This is an SVG. It's building a HTML page for you. That's cool. Cool story, bro. But it won't show in the output. It just shows you all this crap. Okay. And what I've found in Markdown and in Quarto, anytime you use displacy, you need to make it a separate chunk. So don't put it in with another chunk, and make sure you have results equals as is. Okay. That will force it in HTML format to knit to HTML and actually show you the picture, as opposed to just showing you a bunch of junk. Okay, so be sure you use results equals as is. We're almost there. It's running down here at the bottom. Okay. And so let's see. Let's close. But then it does print these giant screens sometimes. All right. So graph, relationship matching, putting it all together. Very cool. Okay. So we had it print some statistics down here at the bottom, but let's just look at it. So you can use the view function when you're working interactively, and that works great. But man, telling it to print, it just like dots the columns. So tidyverse is something right there. But let's see, the subject of the sentence and the subject type, right? The prediction label, executive of, the object of the sentence, US error group, okay? And the frequency of those objects. So clearly something's going on here because these are blank. Okay, and that's probably blank because we didn't tell it to pull persons. Okay, we told it to pull orgs. So we could probably drop you these, but see here where we have executive of. So we have these blanks because we didn't pull the executives' names. Okay. I think that's what's going on. Now, there's only a couple of them in here with the words acquires or sells. So this isn't a great data set because it doesn't have enough examples to really make a cool graph. But that's why when we graph this, you get this blank node, right? It's because there's a blank node connected to all of these, but it's not all the same chairman. If we had the names in there, it would look a little better, right? That we can see that Trans World Airlines and US Air Group are related to each other because they have a connection forward and backwards. And so one thing that I've figured out, so we have org acquires Trans Air Group and org sells, but it can't put both labels on there, I think is why it freaks out. And so if we turn this off, I think it wouldn't still run because it wouldn't allow us to have that same relationship in there twice, but we could find a way to combine them together. So have acquires and sells, or is bought by, okay, right? So you have a couple of, you could make it clear that you don't have a direction there to print this out a little better where the labels would appear on the lines themselves. Okay, we'll see if we can figure that out in class, but at least we got the relationship pulled out and you know how to get the data out of there so that you can use that maybe if you have some other software that you like a little better. Okay. So on that note, that is the end of this section on information extraction. Thanks for tuning along, and we will move on to our next section next week.